All right, here we go. 2016 AP Calculus AB number 4. Let's consider this differential equation. And then on the axes provided, we're going to sketch a slope field for the differential equation at the 6 points indicated. Now, I have already done this actually, so I'm about to move the paper and you're going to see what I have. All we have to do is plug in the coordinates and figure out what the slope would be and then draw a tiny little line that represents that slope. So there it is. There's your answer. Don't want to waste too much time doing something that I think you can figure out quite easily. At both of these points here, the y value is 0, and the x value would be 0 here or 2 here. In either situation, you're not going to ever divide by 0. So you're going to have 0 over -1 or 0 over +1. You have 0 basically as your final answer. That's why those are horizontal. This slope is -1. If you plugged in 0, 1, you'd have a 0 here and a 1 here. 1 divided by -1 is going to give me -1. This slope is +1. And then, just saving some time, -4 here, +4 here. Okay, it doesn't have to be too specific. It just needs to be the right general shape. Okay, part B. Let's read it carefully because I'm just going to tell you what went through my head when I did this. I started reading it and I jumped the gun and I started doing something they didn't ask me to do. So here goes. Number 4, part B. Let y equal f of x be the particular solution. I stopped right there and I started solving this for y. That's not what they asked. To the differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent. There we go. That's what they're asking me to do. Write the equation of a tangent line. And they told me the x value, they actually told me the y value that corresponds to that x value, and they also gave me an equation for slope, so let's come over here and let's deal with it. So the the differential equation, which does represent slope, at 2, 3, would be 3 squared over 2 minus 1. That's going to give me 9. So the slope is 9, and we have found the equation of a tangent line. Do you want to solve it for y? Sure, whatever, doesn't matter. But let's keep reading. Use your equation to approximate f of 2.1. So I want to approximate f of 2.1, and so I'm going to plug a 2.1 right there. So let's keep going. Y of 2.1 is equal to 9 times 2.1 minus 2, and then don't forget we need to add that 3. So we're going to end up with 9 times 0.1 and then plus 3. And that's going to give me 0.9 plus 3, which gives me 3.9, which tells me that, more than likely, the value of the function at 2.1 is ridiculously close to 3.9. Okay, switch colors. Let's go green again. We're going to do part C. Find the particular solution, y equals f of x. Let's stop right there. When you're done with this problem, it should say y equals something. And the particular solution means you're going to find the value of c. So find the value of c, solve for y, to the differential equation, and then they give you that same initial condition of 2, 3. So let's write this out. dy over dx equals y squared over x minus 1. And we're going to cross multiply in a sense, and we're going to end up with dy over y squared equals dx over x minus 1, and we will integrate that. On the left side, it's the same as integrating y to the -2. Might be easier to take a step and just write it like that, and that means that we're going to have y to the -1, but it is indeed negative. Here we have the natural log of x minus 1 and then plus c, and then we'll just bring that down to the next step. Okay, if you want to go ahead and solve for y, you can. You might run into problems though. Trust me, I've tried. I personally think that once you have completely integrated and there's this random c sitting there at the end of it, that you should find out what the value of c is before you do anything else. That's the best advice I have. Plug in a 2 for x and a 3 for y. Again, they said particular solution. So -3 to the -1 equals natural log of 2 minus 1 and then plus c. All right, easy part. Natural log of 1 is 0, so that's just c on this side. And here we have -3 to the -1, that'd be -1/3. So we now know what c is, and knowing what c is means I can actually write the equation again. We're going to still have to solve it. Again, keep in mind they said y equals. So negative y to the negative 1 equals natural log of x minus 1 and then plus c. There we go. It's time to start solving. I think we should change all the signs, and I'm going to do it the way I did it when I worked it out. And then I looked at the answer key and I was like, oh, they did it that way too. Don't have to do it this way, but because that becomes positive and that becomes negative, you can change the order of them. Totally feasible. Don't have to. You do need to change the signs, whether you change the order or not. Oops, forgot that. And at this point, we basically have 1 over y, and in order to get rid of 1 over y and solve for y, then we have to reciprocate, and I mean reciprocate everything. So that doesn't mean this becomes 3 and this becomes 1 over ln. I mean reciprocate the entire side. That is the mathematically correct way of doing it. Okay, I'm going to grab an answer key and we're going to check our work, see what they were looking for, make sure we're right. If we're wrong, we might cry. Here we go. Part A, you got a point for all the slopes that should be 0. That would be these two. And a point for all the slopes that should not be 0. So any of these 4 points that you missed means you would have missed that point. Any of these 2 points that you missed, any of these 2 slopes, I should say, means that you missed that point. So far, so good. Okay, part B, you're going to get a point for the tangent line equation, which we have right there. And they solved it for y. I really don't think that's a massive deal. And a point for the approximation, which is 3.9. Okay, ton of points in part C. 5 points, here we go. Separation of variables. I get a point for simply bringing the x up and bringing the y down. It's cross multiplying. When your y's are on the left and your x is on the right, you're good to go. Antiderivatives. I think we're good on that. This is equivalent to that, and this is obviously the same as that. So we just earned 2 points there. The constant of integration and uses initial condition. So we had to use the initial condition, which we did, and we ended up with a c value of -1/3. So far so good. And then final answer, solved it for y, and that is what they got, and this is what we got. It is the exact same thing. And then they did put an extra little note here that solution is valid for these things. I do not believe that you would get points counted off if you did not put that.